Ever wondered how a computer actually sees? Not just a picture, but how it sees objects, like a pedestrian or a car, and how it knows its direction? This is called object detection. It's used in self-driving cars, in security cameras, and even the fun filters on your phone. Most people think you need a PhD or a supercomputer to develop these, but today I'm going to introduce to you how you can make it in a few simple steps. To keep things simple, I've broken this video into four main parts to follow along easily. So part one is the foundation. We'll briefly explain what object detection is and why we're using YOLO V8, which is the fastest, most accurate model for beginners. Part two, we're gonna have data mastery with Roboflow. I'll show you how to create a data set from scratch by labeling your own images and how to cheat a little by using pre-existing data sets from the YOLO Roboflow universe. Part three is the brain training in Google Colab. So we'll take the data and move it into the cloud. You won't need a powerful PC because we'll use Google's free GPU to train our model. And last part four, is the results. We'll test our model on real images to see how well it learned. So before we click any single button, we gotta learn why we're using these specific tools. So first, we're gonna start with Roboflow. So managing images and labels is usually the most boring and difficult part of AI. Roboflow makes it feel like using a simple photo editor. Second, we're gonna be using YOLO V8S. So YOLO stands for you only look once. Unlike older AI that looked at image hundreds of times to find objects, YOLO does it in one single pass. The S stands for small, which means it's lightweight, fast enough to run on a phone, but powerful enough to be incredibly accurate. There are different sizes for YOLO, but for this tutorial, we're going to be using the small version. Are you ready to get started? Let's head over to Roboflow and build our first data set. So let's start by going into Roboflow. Let's look up Roboflow. And here, just click Get Started. And then once you sign in, you should see your home page first of all. And then if you go here, you'll find your projects. So here is where you can find all the projects that you made, and then you can make a new folder that includes multiple projects, or you can just straight up create a new project. Next, we have the workflow. So this is basically doing like the model or developing the model inside Roboflow and then making the actual system. So we're not going to use that in the video. Next, we have monitoring. This is, if we upgrade, we'll get it. Deployments, explore, which has the Roboflow universe, which we'll get into later. So let's start by going into projects, creating a new project. And we can name it anything really. Let's say, for example, cats and dogs. So that's the title of our project. Next, we have the annotation group, and the annotation group is basically what labels do we need. So this can be only one label, or this can be multiple labels. You can put one label for now, or you can put all your labels if you already know. So since I know my labels, I'm gonna put cat, cat, and yeah. So we're going to make it an object detection model. There's multiple project types. We have classification, we have image, instance segmentation, key point detection, and multimodal. But for this video, we're going to use object detection. And then continue with public. Here, Roboflow offers a tool called Rapid, which helps you label the objects using their own AI or using an AI that you developed previously. So we're gonna just use the traditional model builder for now. As you can see, we've opened our own projects. Here we can upload our own files. Here, this is where we do the annotation, and this is where we can find our own data sets. But first of all, we need to upload our own data. So if you go here, and then we get images of cats. So here, you can, one hack I like to do is I like to open this in one window, and this in another, and then I just drag and drop here. So we have an image of a cat, and we can do multiple images like that. So now we have about 10 images of cats. Let's open this. We'll click save and continue. And here we have the data set. So we go to annotate. In annotate, you can see here unassigned, annotating, and dataset. And let me explain what this means. So in Roboflow, since you can work with multiple people or one project, you can assign each batch of images to each person. But since we're working on this alone, we'll just straight up click annotate images. And here you can auto label, but we'll try labeling it ourselves. Then we click start annotating. Okay, get started. So as you can see here, we have multiple tools. We have the drag tool, which allows us to drag the image. We have the bounding box, which is what we'll use to actually label the object. We have the polygon tool. This is if we want to to draw the annotation in free form. And we have the brush tool. And then we have repeat previous, which is applies all of the annotation from the last image that you annotated. Smart select, label assist, box prompting, but for now we'll use the bounding box tool, and then we'll just choose the object that we want, and here we'll save and enter. And then we do that to the next image, save and enter, and then this image, save and enter. And then once we're done, we can add the images to our data set. And just skip this, add 10 images. So now this is our data set. In our data set, we have 10 images. We'll go back to upload data, and now we want dog images. So we'll put this right here, and we'll look up dog. And here we can just drag and drop these images here. Then label myself. Start annotating. And once we label using the bounding box tool, you'll find here that the label is cat, but this is obviously not a cat. So we'll just write dog, and this will create a new class called dog. Save and enter. And now we have the dog class. So an important tip while you're labeling, the label has to fit the object exactly. So it doesn't, we can't label with the bounding box this whole section. It has to fit exactly the object that we want. So now we're done annotating these images and we can add them to the dataset. So now we have 10 images of cats and 10 images of dogs. Next, we're going to learn how we can import from an external dataset on Roboflow. We now want to expand our dataset. We can import more images like we used and annotate each image. And there's another way by using the Roboflow universe. So we can go ahead, click Roboflow universe. And here you can explore any type of dataset that you want. So for our dataset, we're gonna look up images of dogs. And here you can find multiple datasets of dog. So this looks good. We can take this one. We're gonna go to use this dataset. And now we have two options, fork dataset and clone dataset. So fork dataset, it basically copies the whole project into your workspace directly. And with clone dataset, we can take some of the images from this dataset and put it to our current dataset. So we're gonna go with clone dataset. We go down, we can click here, 200 per page. So now it shows 200 images per page. And if we click, select all the 200 images, clone images, clone, and then we go to our workspace, cats and dogs, clone 200 images. As you can see here, we've cloned these images. So we can click clone more images. Now we're gonna go to a cat dataset. Can pick this one. And we're gonna do the same. So now we have about 420 images in our dataset. Maybe we can add more. So we'll try to add 800 more images of cats and 800 more of dogs. So we'll go to the next page. Select these images and then next page. Click select again. So we're highlighting the images that we want from each page. Now we can go back to our dataset in projects. And here we can see the dataset that we currently have. You can go to classes and tags, and you'll find something interesting here. You'll find that we have our class names, which is cat and dog, but then you might find extra classes. So for me, I have the dog, capital D, and another class name. So to make them all the same, we can go to modify class, and then we can change this to our own class name and this one as well. And then click continue, confirm changes. Done. So now if we look, we have two classes, cat and dog, and we have the count for each one of them. Now for the count, this means that it doesn't mean how many images include cat or dog. It means how many times this class has been mentioned in the data set. So we can go back to our data set. And next thing we're gonna do is go to versions. Here we have the source images. You'll find these images, continue, and we'll have the train test split. So I like to go with the default or 70% train, 20% validation, and 10% testing. So this looks about right. I'll just click save, continue. Now we have a pre-processing step. Now this is completely optional, but I like to put resize, so they're all the same image size. Apply. And you can find many more pre-processing steps like auto orient, adjust the contrast, or grayscale. Continue. We can go back to pre-processing and we can add the auto orient as well. Apply, and then we can click continue. And then augmentation. This is basically playing with the data set so that you can improve your model later on. So it makes it harder for the model and it basically makes the model more accurate in different situations. So we're just gonna skip this step for now. Then click create. So now that our data set is done being made, we can go to download dataset and show download code. But before that, I want to show you something. In Roboflow, you can actually train the model in Roboflow without having to code outside. But what I like to do is I like to download the dataset. I go for YOLO V8, which is the model that I'm going to be using. And then there's download zip to computer, which downloads the folder to your computer. And then there's show download code. I usually go with download code. Continue. And now we have this download code that we can import to or copy to our notebook. So we're going to copy that and we're going to close this. We're going to open Google Colab. And then we're going to make a new notebook. We can name this dog and cat YOLO V8. And then we just paste the code here and then we click play. Now, once it's done, you'll find a file here added called cats and dog. Here you'll find your test images, train images, validation, and you're going to find something really important called data.yml that we're going to use later. So now we want to start training the model. So first thing we're going to do is we're going to import Ultralytics. And Ultralytics is the library that includes YOLO. And you can go to Ultralytics documentation. And here you can learn more about Ultralytics. So we're going to go back, just click PIP, import Ultra, install Ultralytics. So once it's done, we're gonna write from Ultralytics import YOLO. So we're letting it know that we want YOLO from Ultralytics, and then model equals YOLO, and then YOLO V8S. Now there's many versions of YOLO V8. There's N, which is nano, S, which is small, M, medium, and then large. For the purpose of this tutorial, we're going to use S. There is a smaller model called N, which is faster, but this gives us more accuracy and a fair amount of speed as well. And then .pt. And then model dot train data equals data.yml. So we're letting it know that this is where we want to get our data from. This file basically tells YOLO that, look, the images for testing are here, the images for training are here, validation for here, and if we go here, can find images and labels. So it tells YOLO that you can find images and labels here. And then we're gonna write epoch equals 50 and image size equals 512. Now 512, I got it from YOLO when I did the pre-processing. I made it to 512, so I'm just making it standard here. And then I can click run. So I made a spelling mistake here. It's epochs. Run it. And here I can, it says data.yml doesn't exist. So what I'm gonna do is I'm gonna go here, copy path, and then I'm just gonna copy the path here. And it should work now. So as you can see now, it's training it on 50 epochs, meaning it's gonna see the images 50 times. Now, when you increase the epochs, it increases the training time, which means that the model gets to look at the data more. But at a certain point, after a certain point of epochs, the model doesn't learn anymore. So when starting, you can start with 50 epochs. Then when you're actually developing the model, you can increase it to 300 epochs. And then if you look here, you can find something called patience. Let me. Here you can find patience. And if you look at the description of patient, it's the number of epochs to wait without improvement in validation metrics before early stopping the training. So what it basically does is that uh, it looks at the epochs and the results from each epoch, and then it identifies when the model starts to plateau, and then when it plateaus, it stops the training. So we're just gonna stick to 50 epochs. And now you can see here, it's very slow. We're only on the first epoch and it's only doing 2%. So why is that? And that is because we're using our own CPU. We can go to runtime here, change runtime type, and here you can find CPU. Now we can change that to T4 GPU, which is the GPU that Google Colab offers. Can go here, okay, save. And then we can run all over again. So now, as you can see, when it's training the model, it's gonna be way faster. And here we have the box loss, the class loss, differential loss, and we get into it later on. The model, we're gonna go up here. And as you can see, we've trained it on 50 epochs. You can find here the model summary, which summarizes the precision, recall, and MAP. And if we go to runs here, can go to detect, train, and we can see here a lot of images. Now these images are here to represent the results of our model. If you click on results.png, and then we can take a closer look here, you can find here that we have the loss metrics, we have the precision, recall, and MAP. Now, what is that? So we have two types of loss metrics. We have the training and the validation. We have different loss types like box loss, class loss, differential loss. But the general idea is that box loss is like the how accurate the box was. The class loss was how accurate the model was in classifying that object. Differential loss is like uh, seeing like uh, pixel level uh, parts of the image to see how much it was accurate. So what we want is we want the loss to go down just like that, and we want it to look more like that, like this shape that I'm doing, but it's fine if it's like that. And we want the training loss and the validation loss to be almost the same line. You can see here it's not the same, but it's almost the same. That's what we want, for it to be like a perfect line. We have the precision here, and we want it to look exactly like that. We want the line to go up constantly. Same with the MAP metrics. Now, after we're done training, this is a result. You can also find something called confusion matrix and confusion matrix normalized. Now confusion matrix shows how many images were tested and how correct or wrong they were. So shows that there were 341 uh, classes of the cat that were recognized well, and here it's 237. So we can see here that the confusion matrix is looking good because we have the predicted here, we have the true here, and when the predicted matches the true label, then we know that it's going well. So this is the shape that we want. If the shape looks something different, like if this dark shade is here, now the confusion matrix is not good and we need to retrain the model. So if you go to confusion matrix normalized, this shows the percentage of the images that were um, correctly identified, or the objects that were correctly identified. So as you can see here, the cat class is doing pretty well. The dog class, on the other hand, is doing well, but it's also being confused with the background. And one of the reasons this could happen is because the dog images have a lot of variety, uh, unlike the cats, because there's only one shape for a cat, but the dogs have many shapes, sizes, colors. So that could be the reason why it's being confused with the background sometimes. Um, you can explore this. Here you can find, but these are the most important parts, the results and the confusion matrix. You can explore the batches, but I'm not gonna go into it. I'm gonna go straight to weights. Now you can see here, we have two PT files. Now these are our models. What we want to use is the best model, obviously, which is the best.pt. Now last.pt tells us that um, this is the result in the last epoch, but the best is the result in the best epoch. So in most cases, we use best.pt. Now you can click download. And once it's downloaded, you'll have the model file. Now, for the purpose of this video, I made this Python code to use the model that we just downloaded and then to test it on an image of a cat and then to process the result. So for the run inference, we have results equals model.predict. And here we put the source of the image that we want to test on. We put the image size, which is the standard one from pre-processing, and we put confidence. So what does that mean? That means that we want only the bounding boxes to appear for objects that have above 25% confidence. And we're going to see that, we're going to understand that later. Next, we have processing the results. This basically puts a bounding box around the object and shows the image by the end. So this is the cat image that I'm going to be testing on. And I've linked the PT, the model file, already to here. So you can copy that and use it in your own project. So if I run, you can see here we've got the bounding box around the cat, and we've got 94%. If the cat was less than 25%, if the model predicted the cat with less than 25% confidence, the bounding box won't appear. So here we can see the results, and I hope you had fun with this video. I hope you learned something new. Please hit like, subscribe, and share this video. Thank you for listening.